So probability means chance or likelihood of occurrence of an event. What is the probability of an event, occurrence of event? That is called chance of occurrence of event, that is called probability. Examples, exam will be postponed. What is the probability? Candidate will clear the interview. What is the probability? Today there will be rain. What is the probability? These are the unexpected, means we cannot have a clear picture, but there is a chance of occurrence. Now coming to the random experiment, all possible outcomes are known, but the exact output cannot be predicted in advance. That is a random experiment. Random experiment means we know that there are two chances, but which one will occur, that we don't know. When we toss a coin, there may be head or tail. Only two possibilities are there, but we cannot exactly tell what will happen right now. If we toss a coin now, what will be the output? We cannot exactly tell, but only all possible outcomes, we know only two chances are there. Sample space means all possible outcomes put together is called sample space. Event means subset of sample space is called event. All the individual objects, components in the sample space, all the individual outcomes, they are called event. Every individual outcome, his other name is called event. Probability of occurrence of an event. When we say an event occurs, probability of E means event occurs. When we say an event occurs, number of favorable chances divided by total number of chances. So favorable outcomes by total outcomes. Favorable outcomes by total outcomes. This is the formula, basic formula for probability of any event. Probability of any event. And this will be definitely between 0 and 1. Probability will be definitely between 0 and 1. And if we add all the probabilities in one sample space, it should be equal to 1. If we add all the probabilities in a sample space, it will be equal to 1. Now, if you see probability of event A and B, and means intersection, and means intersection. Now, probability of event A or B, or means union. We can also use plus in the place of union. And probability of A not happening. A not happening means in the sample space, whatever A is there, apart from A, all the other things is called A complement. This is sample space and all the outer region of A, but within the sample space. But within the sample space, all the shading is called A complement. If you take circle as A, outside A, it is completely A complement, and that is entirely present in the sample space, yes. So probability of A complement is nothing but 1 minus probability of A. So 1 means this is sample space. 1 means 100% or sample space minus whatever in A, if we remove, that becomes A complement. Now conditional probability means probability of A provided B is already given. Given that B already occurred. Given that B already occurred. That is a way of writing. A by B means what is the probability of A provided B already occurred. For example, if there is rainy season going on, what is the probability of thunder, or what is the probability of tree falls down? Okay, something like that. So already rain occurring, what is the probability of tree falling down? So something like that. Something is already there, and what is the probability of other thing going to happen? And this is the formula for finding it, probability of A intersection B divided by probability of B. And in other way, you can also take it as probability of A by B into probability of B is nothing but probability of A intersection B. Just I cross multiplied in the previous line. And this fashion is easy to remember because probability of A by B is there, denominator B is there, and we have to multiply with the denominator, probability of B. So this is the way of writing. If we have a chain rule, in this fashion, if I have a chain rule, probability of A1 intersection, A2 intersection, A3 intersection, like that up to AN, we can also write it as probability of A1, then A2 by A1, A3 by A2, A1, AN by AN minus 1, and so on. Denominator, whatever is there, it is given. The second probability says, what is the probability of A2 provided A1 is given? The third one says, what is the probability of A3 provided A1, A2 is already known? Okay, that is the meaning. And similarly, in this case, if I take this as equation 1, The same equation 1 can also be written in another fashion. We can also take it as probability of b by a into probability of a, into probability of a. And this is nothing but probability of b intersection a. B intersection a or a intersection b is one and the same. B intersection a or a intersection b is one and the same. We can also write equation 1 like this. We can write b by a, then multiply with a. Denominator, whatever comes, we have to multiply with that probability. And here a by b, denominator we are having b, so multiply with b. Now independence. Independence means two individual events are happening. They are independent of each other. For example, I am writing an exam and one of my friend is also writing exam. Okay. So our passing percentage or our probability of getting pass in the exam is independent of each other. My passing is independent of my friend's performance in the exam. My friend getting pass or fail in the exam is independent of my performance in the exam. Those two are independent events. Such events, we can write probability of A intersection B is nothing but probability of A into probability of B. And here we can also see probability of A by B is probability of A intersection probability of B by A. In this case, if it is independent, if the events are independent, then we can say probability of A by B is nothing but probability of B. Okay. So if they are independent, if the two events are independent, what we can do? Probability of A by B is nothing but probability of B. Why? We know that the formula is probability of A by B equal to probability of A intersection B divided by probability of B. This is our formula already known. Numerator, now independent events means we will have probability of A into probability of B and divided by probability of B. Now, if this probability of B gets cancelled, only probability of A will remain. Okay, that is what written on the left side. So what I have written here is wrong, but you can see this is the thing written. How it gets satisfied, I have shown the proof on the right side. Okay. So probability of A by B is nothing but probability of A. That is the statement. If the two events are independent, A and B are events are independent. So in the proof, what I am trying to do, I am taking equation 1. What is our equation 1 here? I am taking equation 1 for the proof. What is our equation 1 here? Probability of A by B is nothing but probability of A intersection B divided by probability of B. That I have taken here. Equation 1 only I have taken here. Because the two events are independent, in the place of A intersection B, I can write probability of A into probability of B. You can see that point is given over here. If they are independent events, intersection is nothing but product of the probabilities. Therefore, numerator I am writing probability of A into probability of B. Denominator already probability of B is there, they get cancelled. So we will be left out only with probability of A. Hence the statement. This statement, if they are independent events, then we can directly write like this. Similarly, the second one also you can try the proof. Because we have another formula over here. Okay, using this formula, in the place of intersection, you write P of A into P of B, and you will end up with this formula. And this event that the outcome is an odd number. A be the event that the outcome is an odd number. And it is given. The A is given 1, 3, 5. Odd numbers are there. Also, let B be the event that the outcome is less than or equal to 3. Okay. And it is also given. B event is also given 1, 2, 3. I am rolling a dice. You know how a dice will look like. You might have played the game. It will be like a cubicle. On every face, one number will be written. On every face, one number will be written. This is the dice. Okay, 6 faces are there. This is like a cube. 6 faces are there, and on every face one number will be written. You have to roll and play with this dice. On this face, if I take 1, front side 2, bottom 3, side 4, okay, like that. 6 faces are there, 6 numbers are given. 6 numbers are given. When I roll the dice, there is a probability of, okay, on the face of the die. When you toss a coin, on the top, whatever is coming, that we will consider as the outcome. Okay, so bottom, if on the top head is there, bottom there will be tail. On the top tail is there, bottom there will be head, like that. When you roll a dice, 6 faces are there. Coin is having 2 faces only, either head or tail. Okay, but a dice is having 6 faces. When you roll a dice, only one face will come on the top. That will be the outcome. So we have a chance of getting 1, 2, 3, 4, 5, 6. This is the sample space. This is the sample space. When you roll a dice, this will happen. When you roll a dice, these are the events that will happen. This is the sample space. S is nothing but sample space. And these are the events. These are the events or outcomes or on the top face of the dice, or on the top face of the dice, we are having chance of getting one of the numbers. Okay. Now, A is an event, which is an odd number. So this is either 1, 2, 3. Okay, A is nothing but odd number. And B is an event, it will be less than or equal to 3. B is an less than or equal to 3. Now, what is the probability of A? What is the probability of A? What is the probability of A given B? What is the probability of A given B? Okay. So now what I will do? Already given A is nothing but 1, 3, 5. 1, 3, 5. 3 events are present. 3 events are present. Okay. In the total, we are having 6 events. In the total sample space, 6 events are present. Okay. Now, when I want probability of A, number of favorable events, okay, number of favorable events divided by total events. Number of favorable events divided by total events. This is the basic formula I showed you for finding probability of anything. In the first slide, you can see here, probability of E. E means event. Here, I am taking A as the event. Okay, finding probability of A. I am trying to find the probability of A. Number of favorable outcomes by total outcomes. Now, in our problem also, number of favorable outcomes. This 3, 1, 3, 5. 3 favorable outcomes are there. In order to get probability of A, total outcomes are 6. So, 1 by 2 is the probability of A. 1 by 2 is the probability of A. Okay, first thing completed. What is the probability of A given B? What is the probability of A given B? Probability of A by B they are asking. And the formula is probability of A intersection B divided by probability of B. This is the formula. I am making it as equation 1. Already given B is nothing but 3 events are there. B is having 3 elements. And if you see A intersection B, what are the elements? So A is a set 1, 3, 5. Okay. B is a set given 1, 2, 3. What is the set A intersection B? What are the common elements in A and B? 1 and 3 are common. Now, what is the probability of A intersection B? So, favorable outcomes by total outcomes. Favorable is 2 outcomes. Total outcome in the sample space is 6. So, 1 by 3 is the probability of A intersection B. Probability is 1 by 3. Now, in the formula equation 1, numerator value we got. Now, coming to the denominator value, what is the probability of B? Okay. So, number of favorable outcomes divided by total outcomes. So, in B, we are having 3 outcomes or 3 events, and total sample space is 6. Now, it is 1 by 2. Okay. So, numerator A intersection B means it is 1 by 3 value we got, and the denominator probability of B means 1 by 2. If you simplify this, we are having 2 by 3 always probability value will be 0 to 1, less than 1.